stressful if you like are sick for a day or two, right? Like it's gonna feel like you miss a lot. And so this is usually at least somewhat helpful. Oh, yes. I read through all of your things on how I should call on people. Half the class voted for either don't call on people or whoever raises their hands. I get why you'd want that. But that kind of like, it means I wouldn't do my job as a teacher if I only asked the people who already know. Like, that seems kind of worthless. Then nobody ever learns. Then you can like hide in the corner and pretend like you're doing something. That doesn't work very well. So everybody will participate in somewhere. I know some people really get anxious answering, whether it's from your desk, whether it's, just come talk to me individually, we'll figure something out for that too. Otherwise, do know, we have Rexy up here. This is our first line of defense. He is our emotional support Tyrannosaurus. So when you have to come up to the board, he is with you in mind and spirit. Now, you're also allowed to bring up friends with you or whatever too. So like, if you have to answer at the board, you don't need to come up by yourself, because some people just can't handle it. We're also not always just going to come up to the board. A lot of times they'll just call in from the desk. So, how would you guys feel about like popcorn calling is what they call it? Where like, say I call on the first person of the day. That person chooses who's next. And then that person chooses who, you know, it kind of continues on until everybody's answered. Does that seem okay, or would you rather it be random?
That's good.
The random part, I think, just made everybody too stressed out for some reason. Like they felt, they got anxious before every single question. And I think that's what people didn't like. Okay, well we'll try some various systems. I was trying to call on somebody. Who should we go with? Sebastian, do you want to start the day off? Okay. Do you remember what average even means? I figure we'll start kind of low, like we'll work our way up to calc.
Yeah, mean or something.
Okay. Yeah. Do you remember how to find it?
Just like add all of them and then you divide by the number of things you added.
Perfect. Perfect. That's a good start. So like if you're averaging two things, you add them up and you divide by 2. Okay. Average velocity. Well, what you would do is you would take all the different velocities, add them up, and divide by however many velocities you have. But most of the time, you can't actually get those answers. So we rely on something different. I don't think physics has really done anything yet either, right? Okay. This is gonna, anybody who's in physics ties in a lot with our class this year. You'll kind of see that. So average velocity is gonna end up being how far you change in position compared to how much time it took. So rather than adding up all of the velocities, what we're actually gonna kind of do is use how they figure out velocity in the first place. We'll figure out where something starts, where something stops, and how long it took. And that's gonna be the average speed. Now I feel like you guys, most of you probably drive now, right? Okay, so you guys kind of get how that works, where stepping on the gas pedal and just holding at a speed you know, it's kind of constant. But like, you step on the gas real hard and your car accelerates, and so your speed is different here than it is where you end. So it doesn't traditionally stay the same. I don't remember where it is on these pages, but that's going to be kind of the difference between pre-calc and calc. So pre-calc would look for average velocity, and it would look for just take all of them, and if you start at 0 and you end at 10, the average is probably about 5, okay? Calc is going to use instantaneous velocity, and we're going to want to know what is the speed at an exact spot. Now, if you're driving a car, it's easy to tell because you can read the speedometer. But if you're standing next to a road and just watching a car go by, you kind of have to have a way of figuring out instant velocities just by looking what distance it's at. And that's what we're going to try to work our way to. And it doesn't apply to just speed. Calc is the study of change. So we basically are going to figure out and study how things change at an instant for any topic. Okay, so if you need to write this down here, I keep forgetting you guys have the notes to fill out. Average velocity, change in distance, maybe I should say position. It really doesn't matter what term you use as long as you know they're all the same. I think distance for some of you might feel like a different term, but so it's like change in position over change in time. I kind of already talked about instantaneous. Okay, so we'll start with a example, even though it's not like super realistic. It's at the bottom of your page. So apparently somebody's dropping a coin off or something. Yeah, dropping a coin. And so you can use a formula to figure out the position of the coin at any given time. We're going to use 16t squared. That's written weird. To me, it's making it sound like 16t squared stands for average velocity, but this is the position answer we're going to get. Does anybody know how they got this number? So there's one number written in there for you already, I think, right? Sebastian, who's going to help you with this next part? See, what's great is if you have friends and you want to be evil to them, that's what you do. Would we go with Bianca? Oh, I didn't really ask you yet, but how did they get this answer? Okay, so we've got a couple numbers here, right? What do those numbers represent? Okay, good. So you guys wrote down change in position or change in distance over change in time. So this particular set of information, the bottom of the fraction, how do you find the change in time given these two? Yeah, perfect. You take 0.71 minus 0.7. Now, maybe for the little bit harder top, we'll just call it anybody. Does anybody think they know how to figure out the position given that formula?
just write like, since you have the velocity 22.56 time, which is 0.01, then just solve for x on the top. On the change.
Oh, you could. So we're gonna pretend we don't know that yet. Yeah, yeah, no, what you said is absolutely true. You could figure it out because we already know the final answer. I'm just going through the work on how you get that answer. Because we're gonna try to fill out the rest of these boxes. And so I wanna show you kind of how to go about doing that. Okay. That formula up top, when it says 16t squared, what kind of number are you putting into that? I know I heard somebody whisper something. Time, good. So, if you put a 1 in place of t, what it's doing is it's telling you that at 1 second, the position is 16 feet. At 2 seconds, the position would be whatever 16 times 4 is, 64. Now, that position isn't the height off the ground. That position is going to be from where you dropped it. Okay, so how do we use those times to figure out its position at each time? I know, we're starting with math, but it's tough.
Then you have to put in each, like 0.7 first and then 0.7.
Yeah, perfect. So if I want to figure out the position at 0.71 seconds, I'm going to put 0.71 in place of t. So it would be 16 times 0.71 squared minus 16 times 0.7 squared. Now that should give us 22.56 because it's just telling us how fast it went from one time to the other. I see a lot of typing away. Do you guys want me to open up my calculator too to show you how to type it in? I don't know how good or bad you are at the graphing calculator. Do you know how to use the fraction button? That'll be pretty useful this year. Why do you have a calculator but you're not doing anything? You're just gonna get tired if you just sit there and don't pay attention. It's the only way not to fall asleep in here sometimes.
Excuse the interruption. Now, all students with the last name that begins with G through HA, again, last names with the letters G through HA, please go to the loft stage for your pictures. Thank you.
You're gonna find a lot of your difficult classes where you have to like try to use complex thinking. It's super easy to get tired. Like, that's what happens when you use your brain a lot. And/or, this room is always super hot in second hour. Right now it's 77, that's fine. They don't turn on the air conditioning until about 10 o'clock. Saving money. So, doing anything you can to stay awake is awesome. Did you guys get 22.56? Okay. Does anybody need help trying to figure out how to get 22.56? Because the only reason I'm having you try this is because some people aren't great at typing it in their calculator yet, and that's fine, you want to figure it out. Okay. Wait, who answered that? You did. What's your name? Blonde hair.
Walter.
Walter. Okay, Walter. Who's going to help me answer the next one?
Sebastian.
He already, oh, that's true. I didn't give the rules really for popcorn calling. If somebody has answered, they are done until the whole class goes.
Then Marble.
Marble. How am I going to figure out the next answer? What numbers would I put in?
You would put in 0.7. So 6 times
Oh, okay, you got them backwards, but yes.
Oh, yeah.
Yep.
Subtract.
So you actually want to do the second one first, which is kind of annoying type writing this down, but no, correct. And then what do I put on the bottom? But yes, I think you got it down.
0.705. And then minus 0.7.
Perfect, perfect. If you guys can, fill out all 5 blocks. I have a feeling some of you already kind of got going on that. Oh, you already got one. No, way. Right, transfers it. Were these rounded, or was that like what it came up to be?
That's what it came.
Okay. Thank you. I don't know if these are correct or not. I'm assuming so, but, because it certainly looks like it's following a pattern. Also, don't worry too much about like trying to rush to write down all of this stuff, like trying to copy what's up on the board. I do have, so the person that made these notes also supplied a set of the notes that were all filled out. So like after, probably tomorrow I'll put them up. I'll put up the notes that are completely filled out. So don't, if you miss something, don't like get stressed over it. You'll have filled out notes. I won't give you the filled out homework, but I'll give you the filled out notes for sure. Did anybody back these up? Yes? Okay, excellent. What time will it get done? 10. So I don't know if you guys registered what was happening on the table or not. I'm sure some of you kind of just look at the table and you just see these numbers and you start computing away or something. But if you look at the numbers that were chosen, what's happening is the top set of numbers are the farthest apart. The bottom set of the numbers are the closest together. And so this was just kind of a logical way of finding 2 times that were closer and closer together. So if we were to keep this pattern going, there would basically be no time between these 2 numbers. So my average velocity is getting more and more accurate to become the instantaneous velocity. Like, what would have to be the distance between them for it to be called the instant velocity? Like, how far apart would those 2 numbers have to be? 0. There would have to be 0 time distance between them to be the instant velocity. So for right now, all we can do is we can guess or estimate what the instant velocity would be just by making the time very close together. That's how we're gonna kind of estimate instant velocity for now. I'm assuming you can follow this pattern, but what would be our guess for instant velocity at 0.7 seconds?
22.5.
Yeah, 22.4, because all that's happening is you're getting more and more zeros. That's going farther and farther out, so it's definitely getting closer and closer to 22.4. So average velocity is what you guys have worked with before, or just average things. Like, how should I say this? No, Marvel, you went last. Who's going next? Seth? Okay. I don't know if this is a difficult question or not. I guess it just depends how much you remember. What does this formula look familiar to? Like, what formula did you guys use a lot that had the same setup?
I know which one you're talking about, I don't remember the name of it though.
What did you say?
2.5.
Oh, yeah, that's not wrong, but that's complicated. Slope. 2-point formula is slope, it's just using 2 points. So the slope that you guys are used to finding, the slope between 2 points is an average. You're finding the average change in height compared to the distance. So then what we're working our way towards this year is we're gonna be finding instant slope. So average slope only works on a straight line. So if you have a graph that's a curve, the slopes are different everywhere. And so we're gonna be able to figure out the slopes at any spot. And the way we're gonna start that is just by finding two numbers extremely close together. And that's gonna estimate the instant slope. So today is just kind of like an overview of what we're doing. We're not actually doing like a ton of specific things. Was it Seth?
Yeah.
Choose somebody.
Owen. Alright.
See, the downside of this popcorn method is what happens is almost always the same people end up getting picked all the time. Because most people don't feel comfortable to go outside their, outside their box and choose somebody they never have. Not that that's bad. But that's why I stopped using the popcorn method a long time ago. My question is going to be, do you remember what limits were used for?
Yeah. For finding like points that didn't technically exist for x.
Yeah,
For
it's for finding answers that you wouldn't be able to normally.
Mhm.
Okay. Next person.
Don't know her name, but
I don't either.
Olivia.
Olivia. If the time on the bottom was 0, why can't we find that answer? Yeah, dividing by 0 is not a thing. You're not allowed to do that. It breaks math law. Okay. So what we're getting to is we are going to combine limits, which find answers that you wouldn't normally be able to find, and dividing by 0, and we're going to be able to find answers of dividing by 0. So we're going to actually use the slope formula with a distance of 0 apart, and then take the limit of that to find the answer. So we're starting this year by doing limits because we'll pretend you've never seen them before, but we're learning how to find answers we can't find. Units 2, 3, 4, 5 are derivatives. I'm gonna guess you really haven't heard that word before. Derivatives are talking about instantaneous slope. So units 2, 3, 4, 5 is how to find the instant slope of things, and we're gonna combine the limits and the divided by 0 and find instant slope. Now what's really nice, limits and divided by 0 together actually kind of suck. They're like super slow. They take up a lot of paper, they're really, I mean, there's nothing fun about them. You guys actually sort of did it last year. I think I brought this up yesterday. I think this is what you guys did last year? Okay, so what we're gonna do, what we're leading to, is we're going to find the answer when the bottom is 0. So this is actually the slope formula. It's just, if you simplify the bottom, it's just h. No, I wrote that back. Nice X. Like 3 months since I wrote it. Simplify the bottom, and that's just h. So you guys kind of started this work last year. And then we're gonna go through how to find that actual answer. And that'll tell us the instant slope at some place. So that's our first 6 months in a nutshell. And obviously there's gonna be a lot of details. But that's what we're doing. What I was hoping you could do, which today we've got like 7 minutes or something. I know we didn't go through a lot of notes. But I'm also thinking this stuff at the beginning isn't like ridiculously hard for you. It's kind of just number crunching stuff. I was hoping you could start the homework from section 1 in R&R time. Because everybody has to go to R&R today, apparently. Ooh, is there anybody here that doesn't have a first hour class? Okay, so apparently you're coming to my R&R.
Good question. So I technically have PSEL 5th and 6th hour. So do you think I still need to get like called out?
I would ask before you leave.
Okay.
Because they told us the only thing people are excused from is senior study 6th hour. Then they don't have to go to R&R. So I'm guessing PSEL would
I
be
have
the
senior
same.
study 1st hour too.
My guess is no, but
Okay.
I would double check.
Okay.
Yeah, so if you don't have a first hour, it sounds like you're, oh, I wonder if I'm supposed to put you in there.
I think so.
Yeah, because you can't do it yet. Okay, well, yeah, I guess we'll figure that out. It's gonna be kind of a mess today, so. But yeah, I was hoping you could work on the homework during R&R time. Basically just to try, see how it goes. Almost all of the homework should be, oh, actually, page 2 of your notes, I think, uses these acronyms. AROC is average rate of change. So whenever you see average rate of change, that's like the slope between 2 numbers. So that's the formulas that we were doing on that first table. And then IROC, I think it is, right below this. That's the instantaneous rate of change. So they tend to use those acronyms a lot in this packet, rather than just saying average or instant. But instant, you would only be able to do by estimating the average one really close together. And that should be most of the work in the first packet, or the first section. Don't bring anything home tonight. Let me rephrase that. Don't feel like you need to bring anything home tonight if you don't get done in R&R time. I was just wondering, I just wanted you to try some of it during R&R. But I also know some of you might have like 3, maybe 4 AP classes. And if that's the case, then you're probably gonna have that same amount of work in every one of the classes. I just wanted you to work on it for a little bit, like half hour total. So you should be able to do that in R&R. I don't know. Any questions? Are we okay, kind of okay with what we're set up with for right now? This first section really is nothing in particular.